Big news, everyone! The Northern Lights, that breathtaking spectacle usually reserved for the Arctic and subarctic regions, a phenomenon many dream of witnessing in places like Iceland, Canada, or Scandinavia, might just be visible right here, in parts of the United States. Yes, you heard that right. The continental US could be graced with an aurora display. This is a rare celestial event, a convergence of factors creating a unique opportunity, one you absolutely don't want to miss. Imagine vibrant greens, shimmering and dancing above you, pinks and purples, swirling and pulsating, swirling across your local night sky, transforming familiar landscapes into something otherworldly. This is the Aurora Borealis, also known as the Northern Lights, nature's most dazzling light show, a breathtaking display of cosmic energy. Normally, to witness such a spectacle, you'd have to travel to high-latitude destinations like Alaska or Norway to see this incredible phenomenon, venturing far north for a chance to glimpse the lights. But sometimes, under specific conditions, the auroras make a special trip south, gracing lower latitudes with their presence. And right now, in June 2025, we find ourselves in one of those extraordinary periods, is one of those rare moments. A truly special aurora event is upon us. So what's causing this incredible display? What's making the Northern Lights venture so far south? It all begins with a powerful solar event, a dramatic eruption on the surface of our sun. Our sun has sent a burst of energetic particles, a solar wind carrying charged particles across the vast expanse of space. These particles are hurtling toward Earth, interacting with our planet's magnetic field. This interaction is making the auroras extra strong, intensifying the colors and expanding their reach. As a result, they are visible much further south than usual, potentially gracing skies across a wider range of states. This is your chance to witness a truly awe-inspiring cosmic spectacle, a natural wonder that connects us to the vastness of space. And the best part? You might be able to see it from your own backyard without any travel required. So keep your eyes on the sky, especially during the peak hours of darkness, and have your cameras ready to capture this unforgettable moment to preserve the memory of this extraordinary event. In the next sections, we'll delve deeper into the science behind this phenomenon, explaining how this all works, where to look in the night sky to maximize your chances of seeing the auroras, and why this event is so scientifically fascinating, offering valuable insights into our sun and its interaction with Earth. Get ready to be amazed by the sheer power and beauty of nature, by the universe's artistry, a cosmic masterpiece painted across the night sky. So let's dive into this cosmic wonder together and explore the magic of the Northern Lights. The story starts with the sun, our nearest star, the source of all energy for our planet. But the sun isn't just a static object in the sky. It's a dynamic, ever-changing powerhouse of energy, an active, explosive star, constantly churning and releasing vast amounts of energy into space. Not just a steady ball of light, it's a seething cauldron of plasma, magnetic fields, and unimaginable power. Sometimes it erupts with solar flares, sudden releases of energy that can be equivalent to billions of megatons of TNT, blasting out clouds of charged particles, a superheated soup of electrons and protons, called coronal mass ejections, massive expulsions of plasma and magnetic field from the sun's corona, or CMEs. These are some of the largest and most powerful events in our solar system. These clouds race through space, propelled by the immense energy of the solar flare. At millions of miles per hour, a cosmic gale of charged particles hurtling outwards, carrying the sun's energy, a fraction of which is destined to interact with our planet, toward Earth. When they arrive after a journey of millions of miles, they encounter our first line of defense. Earth's magnetic field, a vast invisible force field that surrounds our planet, our invisible shield, protecting us from the constant barrage of solar radiation, deflects most of the particles, diverting them around the Earth like water flowing around a rock. But some get trapped, caught in the magnetic field lines, near the poles where the magnetic field lines converge. These trapped particles, now energized and accelerated, are funneled, guided by the magnetic field, into our atmosphere, specifically the upper layers above the north and south poles, where they collide, crashing into the gases that make up our air, with oxygen, the life-giving gas that we breathe, and nitrogen molecules, the most abundant gas in our atmosphere. Those collisions, high-energy impacts at an atomic level, excite the gases, bumping their electrons to higher energy levels, causing them to release that extra energy in the form of light. Energy as light, a beautiful ethereal glow, the aurora. That's why we see, when conditions are right and solar activity is high, those beautiful shimmering curtains of light, dancing lights, swirling and shifting across the night sky, in the sky. It's a direct result, a visible manifestation, of solar energy, the power of the sun reaching across the vastness of space, meeting our atmosphere. It's a cosmic light show powered by the sun. The colors depend on the type of gas involved in the collision, on which gas is hit, whether it's oxygen or nitrogen, and how high up in the atmosphere the collision occurs. The collision happens. Different altitudes and gases produce different colors. Science in action. A beautiful demonstration of physics and chemistry playing out in our skies, lighting up the night. A reminder of the powerful connection between the sun and our planet. Let's talk about geomagnetic storms. When a CME slams into Earth's magnetic field, it shakes things up. This disturbance lets more solar particles sneak into our atmosphere, especially near the poles. But during a strong storm, those particles can reach much further south, making auroras visible in places that rarely see them. The particles collide with atmospheric gases, exciting them and causing them to emit light, photons. Billions of these tiny light bursts create the aurora we see from the ground. Oxygen gives us green and red, nitrogen adds blues and purples. The result? A colorful, ever-changing sky show. That's the magic of geomagnetic storms. Science never looked so beautiful. Usually, if you're dreaming of witnessing the mesmerizing dance of the northern lights, you'd need to embark on a journey to the far northern reaches of our planet. Think of places like Alaska, or perhaps the breathtaking landscapes of Scandinavia, where the Aurora Borealis paints the night sky with its ethereal glow. These destinations are renowned for their frequent and vibrant displays. But hold on, not this time. Prepare for a surprise. Thanks to a particularly strong geomagnetic storm brewing in space, triggered by intense solar activity, the auroral oval, that shimmering ring around the Earth's magnetic pole, is expanding unusually far south. This expansion dramatically increases the chances of seeing the aurora from locations where it's normally a very rare sight. This means that people in the northern and even central US states are in for a treat, with a potentially stunning aurora display on the horizon. This is a rare chance to witness this celestial spectacle without having to travel to the Arctic or subarctic regions. Keep an eye out for potential sightings in Montana, Minnesota, Michigan, New York, and under the right conditions, even further south. The stronger the geomagnetic storm, the further south the aurora might be visible, if the storm is strong enough. So how can you maximize your chances of seeing this incredible display? The best time to start looking? Between 10 p.m. and 3 a.m., when the night is darkest and the aurora is most likely to be active. And remember, far from city lights. Light pollution can severely diminish the visibility of the aurora. Find a dark spot, away from street lights and other artificial illumination. Ideally with a clear, unobstructed view towards the north, as that's where the aurora will most likely appear. And most importantly, be patient. The aurora can appear suddenly, seemingly out of nowhere, or it might fade in and out, pulsating with varying intensity. Fun fact, auroras aren't unique to Earth. Jupiter and Saturn, those gas giants in our solar system, have them too. This is truly a global phenomenon, a testament to the interconnectedness of our planet and the solar system. It's a phenomenon with a rich history, observed and documented by cultures around the world for centuries. And it's a phenomenon steeped in myths and legends, inspiring awe and wonder in those who gaze upon its beauty. Auroras are stunning, but geomagnetic storms also remind us of the sun's powerful connection to Earth. While the lights are harmless, strong storms can disrupt satellites, GPS, and even power grids. Fluctuating magnetic fields can induce currents in power lines, sometimes causing outages. But don't worry, scientists and engineers monitor space weather and have protocols to protect our technology. These events help us learn more about the Sun-Earth connection and improve our defenses. So, as you watch the lights, remember, you're witnessing space weather in action. It's a real-time science lesson and a reminder of our place in the solar system. Nature's beauty and power, all in one show. People across the US are sharing their awe. Photos, stories, and excitement are lighting up social media. Imagine someone in Iowa or Oregon stepping outside and seeing a green glow for the first time. Pure magic. These rare sightings are bringing the wonder of the Arctic to new places and new people. Families are bundling up, photographers are capturing stunning images, and everyone is sharing the thrill. Even a faint glow is unforgettable when it's so far from the usual aurora zones. This shared experience connects us to the cosmos and to each other. Don't miss this. If you're in the aurora zone, check space weather forecasts and find a dark spot away from city lights. Dress warmly, bring a chair or blanket, and give your eyes time to adjust. Look north. Sometimes the aurora starts as a faint arc before bursting into color. Be patient, and if you see it, share your experience online to inspire others. This is citizen science at its best, a chance to connect with the universe from your own backyard. The northern lights this far south are a rare reminder of how dynamic and amazing our planet is. Go outside, look up, and let the universe surprise you. Science is everywhere, even painting the night sky.